Okay, so here's part I. So we're doing this antiderivative. There are two terms. And you always ask if you're dealing with a one step first. So I look at these two terms and I see that the antiderivative of this is a one step. Okay, but the antiderivative of this is not. So you have to split it up. So this is gonna, so we had two terms inside of one integral, but so now we're gonna split it up and have two integrals. And this is an indefinite integral. Okay, so I bring down the integral symbols, and sine of 3x goes in there, and cosine of x goes in there. Okay, now this is now a one step. Okay, this one is not. Is there any algebra I could do to make this a one step? No. Now I could look for an f of u. Guys, this is it. This is f of u. So u in this case is 3x. Okay. So u equals 3x. So this dx is going to change. This one is not. Okay, this one is all ready to go. So u equals 3x. So now I go du dx equals 3. And then I solve for dx. Okay, so this dx is du over 3. Okay. So guys, I can, no, let me just do this, sorry. All right, so this is sine of u du over 3 plus cosine of x dx. All right. So I have this 3 on the bottom. I don't have any x's over here. Everything is in terms of u. I'll take out a 1/3. Okay, so now I've got these two separate integrals. They have different variables, but they are both one steps, or one move. So 1/3 bracket. Now guys, if you have more than one term, or if you have more than one integral, and you're doing a plus c at the end, you don't need a plus c after both brackets, only after the second one, or the last one. Plus c. Okay. So now, sine, cosine, negative cosine. All right, so the antiderivative of sine is negative cosine. So negative cosine of u. And then the antiderivative of cosine is sine. Sine of x. Okay. Now in the last move, I'm going to have like negative 1/3 because of that. So negative 1/3, and then I'm going to put the u back in. So u is 3x. So this is negative 1/3 cosine of 3x plus sine of x plus c. Okay, so that is the antiderivative. Okay, now this next one. We're in a similar situation, except it's a definite integral. So we need the fundamental theorem of calculus. Final value, antiderivative, final value minus initial value. Okay. So I'm looking at both of these terms. This one is a one step, but that one is not. Okay, so we're going to have to split this up into two integrals. So from 0 to 2, 10x to the 4th dx plus integral from 0 to 2 x e to the 5x squared dx. Okay, so now this is a one step. It's all ready to go. But I'll wait till this one is ready because this is not a one step. Can we do any algebra to make it a one step? No. Okay, so now you've got to look for an f of u. And I see it. The f of u is right there. Oops. All right, so that is the f of u. You can't even really see it anymore. All right, so that's the f of u. So that means that the u is 5x squared. Okay, so now I'll do it over here. So we've got u is equal to 5x squared. Okay, and now I'll circle. So now let me circle what I'm going to change. So I'm going to change that dx, and I'm going to change these endpoints. It's very important when you're doing u substitution on an integral. If it is a definite integral, you've got to change the endpoints. Okay. All right, but before I do any of that, let me take the derivative. So du dx equals 10x. Okay, so now we'll solve for dx, du over 10x. Okay, so that dx is going to be du over 10x, and now I got to change the endpoints. Okay, so I'm getting them from plugging them in. I'm getting the new endpoints from plugging these x values in here, and then then I get u values. Okay, so if 0 goes in here, I'm still getting 0. Just for my notes, I know this might seem kind of silly, but I'm going to cross it off and just say 0 just to show that I tried, or I thought about it. I thought about how it would change. All right, now 2 goes in here. So this is 5 times 4 now, that's 20. So that's 20. Okay. So now, I've got, this integral is the integral from 0 to 20, x e to the u du over 10x. Okay. Now, this x is on the top. Think of that over 1. That x is on the bottom. So these are canceling. Those are canceling completely. And I'm going to pull out a 1/10. All right, so here's this plus sign. I'm going to carry it down, plus. So I'll pull out a 1/10 integral from 0 to 20 e to the u du. Okay, and then this one, I'll bring down there. So the integral from 0 to 2. Okay, so now we got two integrals, different variables, but they are both 1 steps. So I'm opening up a bracket for the fundamental theorem of calculus. So no plus c. 2 and 0 go at the end. Plus sign. 1/10. Open up this bracket. 20 and 0. Okay. Now for the antiderivatives. So it's going to be 10x to the 5th divided by 5. Okay. And then the antiderivative of e to the u is e to the u. Guys, with this, I know that we've done a lot of indefinite integrals before this. You are not plugging the u back in. We changed these endpoints to u values, so there's no need. We don't have to plug the u back in. Okay. So this here, that's 2. Just to save room, I'm just going to write that. All right, so that's 2x to the 5th. Okay, so here we've got 2 times 2 to the 5th minus 2 times 0 to the 5th. Final value minus initial value. Okay, that's net change. Plus. The 1/10 comes down. I need parentheses. 20 goes in, so e to the 20th minus e to the 0. Okay. Guys, we've got to know any base to the 0 power is 1. Okay. So what we've got, all right, so this here, this is 2, that's 0. And then this is 2 times 32. 2 to the 5th is 32. So 2 times 32 is 64. All right, so this right here is 64. So 64 plus 1/10 e to the 20th minus 1. Okay, Now, guys, this is a fine answer. You could actually stop here if you want. This is a number. But like suppose it was multiple choice and you were trying to simplify this to match it to an answer. What can we do? Let's just do a little bit of simplifying, but you could have stopped there. Plus, oh, okay, you know what? I could do e to the 20th minus 1 over 10. Okay. Alrighty, and if you want, you could get common denominators. So 10, 10. So we're getting 640 plus e to the 20th minus 1 over 10. Okay, so this is 639. So I've got e to the 20th plus 639 over 10. Okay, all right, guys. So, may stop here. All right, so I'll say you may stop here, assuming you can't use a calculator. You may stop here. Okay, guys.